All right, here we go. Here we go for Riley's Greatest Hits number 2. After listening to the last one, sorry, I need to put some more energy in my voice. So I will try to be happier and have more energy. But it's kind of hard to have energy when I'm sitting down in a chair doing this and talking to myself. So enjoy. Hey, if you're falling asleep after the last video, wake up and pay attention. Something will happen to you. I don't know what yet, but something. So like seventh period, pay attention. Don't write on my desk, Cole and Jaden and Joe, because you're still cleaning them. Okay, let's start with electron arrangements. Hopefully everybody's on page 18. And just so you know, if you want to listen to this again, this will be on my blog. So if you're not doing anything over the weekend, check it out. Okay, electron arrangements are another. Basically, electron arrangements. Sorry, wrong thing came up. Let's go with what color today? What color should we pick? I'm thinking red right now. No, let's go blue. Go some Bonneville High School. Okay, electron arrangements are basically an address system for the electrons. Electrons are what make chemistry possible. Chemistry is all about the electrons, so we care where they are at. If we know where they are at, then we're going to be able to understand them better and make them function better, and we can do things with them. Electrons are how computers work. Electrons keep your body functioning. Electrons are how we get electricity to every place in the world. Electrons are everything. Protons are important, neutrons are important, but electrons blow it out of the water. So elements are arranged in the periodic table according to the, hopefully you know this, atomic number. The atomic number corresponds not only to the number of, guess the blank, sorry, it is protons in the nucleus of the neutral atom, but also to the number of, starts with an E, ends with trons, electrons in the atom. Electrons are negatively charged, protons are positively charged. So that makes it a neutral atom. The arrangements of electrons in an atom is also called the electron configuration. Configuration and arrangement are synonyms. Now, just like you, all things in nature seek to be at the lowest possible energy level. Think of objects falling from the sky seeking the lowest potential of energy on the Earth's surface. So let's say that I have a building right here that's 10 stories high. So we have windows on it. Windows everywhere. Windows. And I put, let's say, an elephant up on the top of it. That's an elephant. Again, I know you love my pictures. That's actually not that bad of an elephant. And I put an elephant on the top and I make him walk over the edge. What's going to happen to him? Well, of course, he's going to fall down because it's lower energy down here. The elephant doesn't want to hang out there. It takes a lot of work. So he's going to fall down and something may happen to him. So, same is true for electrons. Electrons want to be at the lowest possible energy. Now, the same is true for electrons. They want to be the low energy level. Now, as we talked about in the last video, the s orbital is the lowest energy orbital for an atom. The most stable or ground electron configuration of an atom is that in which the electrons are in the lowest possible energy states. Now, hopefully you've got the idea that atoms want to be at low energy. They don't like to be at high energy things. So now, okay, keep in mind when I'm talking about orbitals here, okay, we have our nucleus again. We have the s orbital, and then we have these crazy looking p orbitals. Okay, and they go like that. They follow the x, the y, and the z. We'll talk more about that on Monday. But the orbitals of an atom are arranged in order of increasing energy. So the further you get away from the nucleus, this is high energy, and close to the nucleus is low energy. How many of you, when you were kids, you had the little leash that attached you to your parent, right? So this is you and your mom out shopping, and your mom has the leash that wraps around you so she could keep you by. Okay, because you always want to be by your mom. I don't know. Okay, and the further you get out, the more energy, the more mischief, the more chaos you got into. So your mom kept you close by. Same's true here. The nucleus wants the electrons close to it. The electrons want to be close to the nucleus. Now, in the quantum mechanicals model of the atom, that is the wave mechanical model of the atom. The principle, now this is where we get some trickiness going on here, so bear with me. The principal energy levels, being 1, 2, 3, etc., of electron orbitals are divided into sublevels. Now think of this as like your house. Okay, so I'm going to draw a little picture here. This is your house. Now in a house you have different floors usually. So you have your first floor, your second floor, and an attic. That would be like the energy levels. Now on each floor of your home though, maybe you have a couple different rooms, right? So maybe you have a bathroom and a bedroom on one floor. Then you go up and you have your kitchen, your living room, and your um, game room. Okay, but that's how atoms are. Atoms have their main energy levels, and then each level is divided into a room, like in your house. So that's kind of important to know because that's going to make some sense later on. Let me switch colors again just to spice up life. We're going to go back to black. Oh wow, that's like getting way complicated now. There we go. Sorry, it was harder than it should have been. Okay, based on the energy of an electron would release if it should fall to the, you should be thinking ground state. Each energy sublevel corresponds to a different electron cloud shape. So back to our house model. Just like you call one room the bathroom and one room the kitchen, we call each sublevel the S, the P, the F, and D. The cloud shape is where there is a high chance or probability of finding the electron. That's our best bet. Okay, again, back up here to our model of the atom. Right here, we're going to find the electron in these clouds. Okay. So what you should be getting from this, basically that we have levels. Okay, levels are divided into sub-levels, just like in your home. Each floor of your house has different rooms. Each level on an atom has different sublevels, and they are called the S, P, D, and F. Now, we have four main rules to locate and keep track of our electrons. Okay, first off, electrons enter the lowest energy level first. We call that the Afuba principle. Second, no orbital or sublevel, so S, P, F, and D, has more than 2 electrons, the Pauli exclusion. And these you will need to know for the test. Like, okay, how we do it. Okay, and then no electron pairing takes place until all orbitals are half filled. And if we get half filled or fully filled levels, they are more stable. Okay, stability is the key. We want to be stable. So right now we're going to pause this video for a second because my time is about up with this video. But basically we need to know that we have levels. Within each level we have sublevels, and those sublevels are called S, P, D, and F. Okay? And know the rules. We'll talk more about these rules as we do them on the next one.